Now I'd like to welcome up our next speaker. He's with Flickr. He was here last year talking about their geo work, and they did a lot more amazing stuff this year, so we invited them back. Please welcome up Aaron.
Hi, my name's, oh, there it is. Hello, everyone. It's a pleasure to be back. My name is Aaron, and I work at Flickr. We're about 2.5 years into the geotagging project, and we're coming around the corner on 115 million geotagged photos, which is pretty exciting, especially because about 70% of them are public. That means I'm going to show you a very long quote by Clay Shirky. This has nothing to do with geography. It was from an essay that he wrote about the recent Amazon fail kerfluffle. And there's one piece that I want to highlight. And that's the notion that metadata is worldview, and that sorting is a political act. And I think this is an important conceit in general, and it's an especially important conceit for us because a big part of what we're doing when people geotag photos is trying to interpret and decipher the difference and the distinction between location and place. When someone geotags a photo, they're telling us a lot more than just that their photo was taken somewhere on a grid. This is what we call reverse geocoding. We thought it was a solved problem when we started. Apparently it wasn't. And this is what it looks like both for us sometimes and for the users. They have no idea what we're doing, and we're trying to understand what they're telling us. One of the reasons that it's so difficult is that the data we're working with is limited. We're working largely with bounding boxes and points. And the problem with bounding boxes is that they're a blunt instrument. They're great, they're very fast, but they're not terribly subtle. And this is the problem in a nutshell. They overlap one another. Quick example. I geotag a photo at home, and we draw a radius and we say to our data provider, show me all the places that you think that intersect this radius. And we get back more than 4, but just as an example, the reality is it looks like this. These are the neighborhoods where I live. The problem is that sometimes what comes back is this. So you have 2 overlapping bounding boxes, and the problem is compounded by the fact that neither one of them is right. So this is what my job looks like some days. I spend a lot of time trying to codify human subtlety, or that's just fancy talk for saying trying to teach computers to read people's minds. The bad news is that it's a hard problem. The good news is that it's possible. We've been surprisingly successful in this. And what we end up doing is every time you geotag a photo, we associate that photo with up to 6 places on a hierarchy. The hierarchy looks like this. So a concrete example at home is what you see here. Taken in the mission, it has a unique identifier with it. They're called Where on Earth IDs. Tyler Bell from YGO was talking about those yesterday. We love them, even though he wishes I wouldn't call them Where on Earth IDs. So that got us thinking over time. We have a lot of points. Maybe if we started to fill up buckets based on the Where on Earth IDs, maybe we could start to get something that we could use that was more friendly than a bounding box. So we did that. We made a bucket for every single Where on Earth ID, went through all the photos, filled up the buckets. And so the next step is to connect the dots. Easy, right? Apparently not. Again, we thought this was a solved problem. Turns out it's a hard one. There are a number of different ways to do it. You can do convex hulls, you can do k-means. None of them are, we eventually settled on something called alpha shapes. The easiest way to think about alpha shapes would be to imagine that all of those points are the photos associated for a given neighborhood, and we trap them in a giant block of ice cream. And then the trick is to take a scoop and to scoop out the ice cream until we hit one of those points. So the alpha in alpha shapes is the size of the scoop. So if the scoop is too small, you scoop out all the ice cream and all you're left with are tots and you don't get anything. If the scoop is too big, you get a sort of clunky shape that doesn't tell you anything. We opted for the third alpha shape. In retrospect, maybe we should have done interior rings, but the Department of Small Steps said, take small steps first. So one of the questions that leads is, well, wait, isn't this just a feedback loop? Aren't you just going to parrot back the bad data that you already have on hand? The answer is no. Because before we started rendering these shapes, we also launched the corrections project, which we talked about last year. Corrections are simply, we allow you to say, no, you're wrong, it was taken in this neighborhood. So the buckets get sorted differently. We wrote, we got Skylar Earle to write a program for us called Cluster, because we have no good names. And Cluster is open source software. It's available for anyone to download and use under the GPL2. We thought that since, we were hoping that someone had already solved this problem for us, so we wanted to give something back. This is how Cluster works. It's a command line tool. It's very, very simple. It takes a text file containing points and generates a shape file, and optionally an alpha value. That's all it does. It does that by design because we wanted this to be a general purpose tool and not something specific to Flickr. So what does it look like? We were floored. We were stunned when we started seeing these. We were hoping for something that was a little richer than a box, just something that we could do error correction with. What you're seeing here, the pink shape is the United States. That's the shape that we think it is. And the white shapes are the individual states. Texas. Everyone loves this one. And you'll see the bit that sticks out into the Gulf. I'll come back to that in a minute. This is the shape of Hong Kong International Airport. This is the shape of the Troubles. These are some early screenshots from when we were trying to figure out what the optimal number of records to include in a given shapefile would be. Just quickly, for continents and countries, we chose 6, and everything else we boil it down to a single record or a single shape. It's probably some room to finesse that. So we do this all the way down to the neighborhood level. And what you start to see is, one, you get to visualize the truism that all neighborhoods are disputed. And then you also get these weird, freakish neighborhoods that spill out into, in San Francisco's case, the Bay. But that's really interesting, because what you're seeing is the shape of people looking at San Francisco. So you start to get a different perspective on this idea of place and what the shape of a place is. It's not all fun and games. We can actually roll this back into the reverse geocoding, just to give you some idea of, I showed the screenshot before of the bounding boxes all intersecting one another. Here's an example. 7 bounding boxes, only 2 of those shapefiles are actually relevant. More recently, we've been experimenting with something called donut holes. They're called donut holes because that's kind of what they look like. And the idea with donut holes is to try and define the shape of a place, not using the points for that place specifically, but to aggregate all of the points that are children of that place. So in this case, what you have here is the blue shape is the outline of metropolitan Paris, and it maps more or less to the commuter line. And that is the city of Paris today. But what you get in the center is much closer to the old city, the city walls, what everyone thinks of as Paris. And then you also get Versailles down on the bottom, and if there's anyone from Paris here who can tell me, I think the one off to the side is the neighborhood where they had the riots a few years ago. London, same thing. Tokyo, New York City. This one is fascinating to me because no one manages to get New York City right. Nobody. And if you look at the giant pink shape, it's clear that we don't either. I mean, I have no idea what that's supposed to be. So we ran the donut hole algorithm through, and what you get is the big shape is the island of Manhattan and most of the 5 boroughs. And it includes the Jersey Shore, which New Yorkers would probably take exception to, but I would argue is a pretty reasonable representation of the city as people actually live in it. And then there are these 3 funny outliers. The reason, there's actually 2 outliers. The one all the way up the top is connected by a thin bridge. In the world of we're not always sure why we make these decisions, donut holes are allowed to have 3 shapes. Well, it turns out, Coney Island, the Bronx Zoo, Shea Stadium. That's New York. The other interesting thing about the donut holes is that we can start to use them to trim other shapes. This is France and Corsica down in the bottom, and you'll see that the red shape is the donut hole shape, the white shapes are the individual regions. And if you don't want the water, then it's not a question of wanting the water or not. The interesting thing is the differences and what that can start to tell you. I show this mostly just because it's my favorite shapefile ever. This is Vietnam. Italy, again, the same sort of thing where Sardinia pops out in the shapefile. The water part is, this is hand-waving territory right now. I don't know where it's going to go, but I think it's an interesting avenue because we typically think of water as the absence of place, and yet it is the anchor for most places. People in Oakland and San Francisco still relate to the bay. People in Paris relate to the river. People in London to the Thames, and so on. I don't have much more to say about that. I would love to talk to people about it, and I just think there's something there. And I think the shapefiles can maybe help us sort of parse that out. Recently, Julien Boussec did a much better job of describing this. This is a map he made where he took the Palestinian territories and depicted them as a series of islands. So, no GIS data was harmed. All of these shapefiles come from nothing but geotagged photos. This is really cool. And they were built with cluster, which means that anyone can make these shapes. You can get the shapefiles out of the Flickr API. This is working code. That's about as hard as it gets. Again, this is the input file for cluster. We've been keying off of where on earth IDs. You can key off of whatever you want. Tags is the obvious example. I'm waiting to be amazed. You can make maps with these things. Recently, cluster was included in the Maps from Scratch EC2 AMI that's been put together by the Stamen design crew. So it's just there. No one has to worry about installing it. And I've written some bare bones client server implementations, which means that you can spin up an EC2 instance, pass it a file with points, and spin the EC2 instance down in about this much code, literally. And this is the sort of thing you can do. These are all the geotagged photos from March 23rd, rendered 10 times with 10 different alpha values. And each shape was used to make a mask on top of just a plain old blue marble map. Pretty. But wait, there's more. Data. Starting today, we've made a public data set of all the Flickr shapefiles available for download and use under the Creative Commons Zero license. This is public domain data. We want people to use this stuff, and we want people to feel comfortable and confident to do so. So if this is what it takes to encourage other people to do the same, then we're happy to do it. There'll be a blog post later today, but you can download the shapefiles right now here. again, we want people to make shapes. We want to use their shapes, and we want them to share them. Some closing thoughts. Hug a psychogeographer. I have 24 seconds left, and 15 minutes isn't enough time to talk about psychogeography. They're a weird and goofy lot, and they're pretty short on working code, but they're also right. And I think that this idea of wearing geography as perfume is something to pay attention to. It's worth paying attention to if for no other reason than the current group of people who are thinking about ubiquitous computing and urban computing take the psychogeographers as their patron saints. And this is even more true if you accept Dennis Wood's argument that the noted urban planner Kevin Lynch was a psychogeographer. I know. So it's worth paying attention to. Very quickly, we've been here before. This is a bit like Here Be Dragons territory. And I understand that when the technology came along to make more and more precise maps, everybody jumped on it because before that, all we had were Here Be Dragon maps. And people would like a little bit of precision. But we can have our cake and eat it too at this point. We can do what Matt Jones talked about as maps becoming the territory. And thank you.